Hello friends, this is ML with AP. Welcome back. Welcome to the third video of the Python Fundamentals series. In the last two videos, we got an understanding of Python basics, its origin, its history, various IDEs like Jupyter, Anaconda, the package manager, and in the very last video, we discussed about syntax and semantics. We also looked at the Python simple data types, like int, float, and string. Okay. One more important thing which we discussed last time, which I want to recap, is how Python stores its data and why Python is known as Python is dynamically typed language. If you recall that how we were talking and discussing about the variables are just references to the memory block locations and not the actual container. If you have not watched the earlier two videos, I highly recommend you to go over there and watch my previous two videos. It will give you a very good understanding of what we are going to discuss today, and it will help you in understanding the today's concept also. What we are going to discuss today? Today we are going to discuss few more compound data types. Okay. Now, if we have already discussed the int, float, and string, they were more simple data types. Now we are going to discuss compound data types. And now what is so compound about it? We'll discuss just in a bit. We'll primarily be discussing list, tuples, dict, and set. Okay, these four type of objects in Python we are going to discuss today. They are called compound because they act as the data types which stores int, float, string, a combination of those, and sometimes it can also store themselves as well. And we'll just see the example in a few minutes. Okay, so let's see. So if there is a list type of data, it can contain int, float, boolean. We discussed this also last time. It can contain a string, which is a straw. It can contain lists also, and it can contain any of these other compound data types as well, right? So now I think, friends, you are getting a picture that why these are called compound data types. Okay. With that being said, let's move on. Okay. Let's see the various data types, how we define various data types based on what they store. Okay, what data they store, or rather what data they store. Data is stored. Okay, so if we have to store some text related information, you can guess it. What is the preferred way of storing? In a string. So anything which is character or text bit, we store it in a string. If the data is numeric type, okay, we have int, float. We also have something which is complex. Complex is a complex numbers. This is primarily used in mathematics. So if you have seen the notation, something like a plus ij or something, or I b, where a and b are some integers and I is a complex number. Okay, so if you do not know about complex numbers, nothing to worry. Most of the time we are going to use only int and float, right? It is sufficient to understand that, okay, complex number is something which is used in mathematics to deal with coordinate geometry. At this moment, that understanding should be sufficient. Okay. Now, if we have to store sequence type data, what are sequence type data? They are like sensor data. They could be something like time series where any system at every regular interval it is giving some data. So for example, we can think of stock prices. Okay, stock prices on the the index or any of the stock prices on the exchange vary every minute, let's say. So this can be considered as a time series data. If we have to store these type of sequence data, then the preferred our data type or object to store that would be either list, we can store in tuple, or we can store in range. Okay, range is another data type. Okay, let me just give me a second and I will scroll it down. Moving on, if we have to store a mapping type data, what is a mapping type data? Let's say we have to store something in a hash map. It is called hash map. If you are aware about that, well, if you are not aware, let me just explain it into a quick. So it will be something like key value pair. Key value pair. As an example, let's see if you have to store the name of the countries of the world, and capital city, and its capital city. In this case, okay, capital city. Okay, this is good. So in this particular case, the country's name will be your key, and your capital city will be your value. So it is like one-to-one mapping. Okay, if you have to store something, that type of data where there is an object which is a key and another object which is a value of associated with that, in this case countries, you can think of many such examples, right? The preferred data type to store that is dictionary. In short, we call it dict. Okay, moving on, the another is if you have to store set type of data. Now what is set? Again, this is a mathematical concept. If you know, it's very good. If you do not know, even then probably we'll discuss just in a while. At this moment, just try to understand that set is something which is we are binning, or we are putting things into various categories. Okay, so let's say we create a song playlist. For example, we create a song playlist in YouTube or in a Spotify or anywhere, right? Now we go and pick and associate in our playlist, right? We pick a song which is, let's say, rock song or a soft song or a devotional song or a Bollywood song, and we'll associate that into the playlist. Okay, now what we are doing, we are setting these, or we are categorizing these songs into various categories, right? That is essentially what set is. Okay, we'll be discussing this today, but the preferred object type to store set type of data is set. If you have Boolean type of data, right? If you have Boolean type of data, then we already know and we have discussed that we have a bool object also, right? Of an object which is given by Python by default, which is of a type bool. Now, okay, now let's move on. I hope, friends, till now all these things are pretty much clear, right? Now let's go, and before we jump into discussing list, dict, sect, and tuples, let's try to understand one more thing. Okay, and for this, friends, I will take you to the Jupyter notebook. Let's go over to the Jupyter notebook. Here is my Jupyter notebook. Okay, let me define something as, let me initialize a variable x, and which is equal to 2. Now if I have to get the type of this, that what is the data type of x, I will say it is int. Perfect. 2 was an integer, and since Python is a dynamically typed language, because x is only referencing to the memory block which is storing 2 and not the actual container for 2, we know that it is int. Okay, now let me say that what if we have to, this is the type. The other thing is typecasting. What is typecasting? When you want to convert one type of data into another type of data, how you can do? Let's see that if I have to convert x, which is an integer, now to a float. Simply what I will do, I will say float x. Okay, it became 2, right? Now this float is converted to, let me see the type of it. Okay, so the type of, when I did a type casting of X to float, it became float. So this is one of the concepts that how you can find the data type or the object type, and how can you do casting also, right? Okay, now let's move on to the let me get a markdown cell over here. Okay, so let me define a list type which is my list. Okay, I'm defining it, and I'm storing 1, 2. I'm storing also a character here. Okay, and I'm again storing a float number. Okay, and I'm running it. Now I'm trying to find the type of my list. It is created a list type. This is an object which is of the type list. Okay, now let me see that how this is my list is defined by a square bracket, right? This is how it is defined and initialized. Now let's move on to tuple. So let me define another my tuple. Okay, we'll discuss just in a while that what these data types are. Okay, so I'm defining 1, 2, 3, 5, 6 something. Okay, and I'm entering, and I'm again doing the type my tuple. It's a tuple type. Similarly, if I have to define a dict type, I will initialize a variable my dict. Okay, and if you friends notice, this is the square bracket, this is a small braces, a small parenthesis, and this is a curly braces, right? So every data type has a different way to initialize. Okay, a different syntax, if you can. Okay, so the dict, as I was saying, it is a key value pair, so I need to supply two things. Let me supply a. Okay, or better example would be like India, which we are giving, and it is separated by a semicolon, and the capital would be New Delhi. Then the second will be let's say I will give the state capitals also over here. So in the second will be like Karnataka. It is associated with Bengaluru. Okay, let's move on to, we'll go to, and it is separated by a comma. We'll give Maharashtra, and its capital is Mumbai. Okay, now let me run this. Okay, now again I'm trying to find the type of my dict. It will say it is a dict type object. Okay, the last but not the least, it's set. Now set, let me define a new variables my set. Okay, this is also used by a curly braces. Okay, but the difference is there is no key value pair over here. Okay, so I'll define 1, 2, 3, and this is define my set. Now let me do a type of my set. My set, this is a set type variable. So now we have learned that, okay, all these 4 compound data types, how do we initialize? So we initialize our list with a square brackets, tuples with a small braces, dictionary with a curly braces, but it has a syntax which is a key value pair separated by a colon, and the individual elements are separated by comma. Okay, set on the other hand again is defined by a curly braces, but there is no key value pair concept over here, and it is the individual elements are separated by comma. Okay, so I hope these things are well understood now. Now we will go ahead and dig deeper into our list. Okay, and subsequently we'll go further into list, sets, dicts, and tuples, all of them. Okay, so as I was saying that we already have defined a my list right over here. We'll take that as an example. Okay, so now list, I was saying that it can be defined with a square bracket. There is also another way to define a list or initialize a list. Let me do a new list. Okay, I'm creating another variable new list. What I will do is I will use the keyword list, and I will use two small braces. Okay, and I will use 1, 2, 3, or whatever numbers I have to initialize at the list, and I will run it. Okay, now let's see what is new list. New list is 1, 2, 3, and 4. This is another way of, either you can initialize it with a square bracket like I have done over here, or you can initialize with the list. This is a constructor, right? If you are coming from an object-oriented programming, then constructor is the function to instantiate an object, right? Just think it in a, even if you do not know oops concept, just think it something like, okay, if I have to initialize a new data type, I have to use this particular method. That's it. Okay, this particular keyword I have to use. The only thing which you have to remember is that there are two ways of doing it, one through a square brackets. If you are using the constructor or this particular keyword list, you have to specify two small parentheses and then define. And this type of constructor behavior is common for all the data types. So whether you are constructing set or dict or anything, you can use dict keyword, you can use set keyword, you can use tuple keyword. So this will remain constant. Okay. Okay, now since we have defined, let's get the another concept over here, that how do we access the elements. So my list, let's see my list over here. Okay, my list is, first element is 1, second element 2, third element is ml with ap, fourth element is a float which is 2. What is list? List is an ordered collection. When we say ordered, that means this order is predefined, that 1 is sitting at the 0th location, 2 is sitting at the first location, ml with ap is second at the second location, and 2.o is second at the third location. Okay, now in Python list, it is a zero based indexing. That means the counting starts from 0 and not 1. First element is 1, but its index is 0. Okay, second element is 2, but its index is 1. Let me just go quickly over here, and I think I have pasted something over here which made. Let's say this is a list over here, PROBE, and individual characters of the list. Now this is my first element. The index for that element is 0. This is my second element. The index for that is 1. Third element 2. Fourth element 3. Because since the counting is starting from 0, it is offset by 1. Okay. Now let's if I have to, let's say, ask you that access this particular element which is 1 2 third element, how will write? We can access it by, now it's a 0 based indexing, so this is 0th element, this is first element, and ml with ap is second element. We'll put 2 over here. Okay, with a square braces and put 2, I can access my third element. Okay, now if I have to access my fourth element, my fourth element is 2.o, but in a 0 based indexing it's 1 0 1 2 3. I have to put 3 over here and enter. I got 2. Okay, so this is what is meant by 0 based indexing. Okay, and so along with indexing, one important concept is slicing also. Okay, now let's see how we can slice the element. For this, let me define let's see, new list is also okay. New L, I define a new thing, and I will define it as slightly bigger list. Okay, and I will do, let me define it in order so that probably it will be easier for us to understand also. Okay, so now there are 13 elements, okay, in new one. This is a new list. Okay, if I have to get the length of this, there is a function for that, and I have to pass the name of the list, and it will give you. Okay, did I define this? I don't think I ran that. New L. Okay, I think I write 1 over here and L over there. Did I do that? Oh, okay. Yeah. I defined not new one, but new L. Okay. This is new L. Okay. So this has a 11. Is the length is 11. Okay. Now the other thing which we can do is there are, as I was telling you in the last video also, there are various methods or functions which is associated with each of Python objects, and how you can access that with a dot operator. So here is my new list. I'll put a dot over here and I'll put tab. If I put tab, the IDE will show me all the functions or methods which are available for this particular object type, which is list in this case. Okay. So for list, let's see what are the things which are available. We can append. What it does append, let's see. Okay. So if I have to press append, and we have to put a parenthesis over here, append nothing, but as the name suggests, it will go ahead and append a new element into the list at the end. In this order, let me append 14. Okay. Now again, I'm trying to, the 14 is added over here. Similarly, all the other, let's say dot operator, again tab. Clear means it will empty the whole list itself. Okay. Append was appending at the end. Clear is it will clear and empty the list. Copy, you can make a new copy of it. Count, you can count the number of element which is present in the particular list. Suppose you want to count the number of tens in a very big list. How many times 10 has appearing? You can supply 10 as a variable to the count, and it will give you the result. The result will be the how many times 10 is appearing. You can extend, you can index. If you have to insert, you can insert it all. Now the difference between append and insert is that you can insert in between also, like you can choose that where to insert. Okay. Pop and remove are both removing. Reverse is like you can reverse the let's see this. So this will become much more clear. Okay. New L dot reverse. Let's see what it will do. Let me print new L again. Okay. Did you see that? So if there is a list and you have to reverse the list, the function is reverse, and you can close it with parenthesis. Okay. This is how the reversing works. And if you have to reverse, it's an easy function. There are other ways also programmatically you can write a for loop and you can do reverse. There are other ways also which we are going to discuss just in a while. But this is a function by default, a method which is available. Okay. Now let's see if you have to, what will happen if I do new L plus my list. Okay. You saw that? My list over here was, this is my new L. Okay. Till here my new L is there. After that it has concatenated my list also, which was 1, 2, ML with AP and 2.0. So a plus operator or an addition operator on a list works in the same fashion as if it concatenates two lists. Okay. Now we have already seen the other methods with the dot operator, what it can do, right? Now let's see something. Okay, one more thing. Why Python is able to store? Just think for a moment, right? We can store any object inside a Python list, right? Let's see if we have to store a new list. Okay, I'm defining and I'm storing over here one. I'm storing a string. I'm going to store a float variable. Let's store a float variable, and I can also store a string as well, 0, 1, 2. Okay. Now new list. If you see, it is storing an integer, a string. Okay, I think I did a mistake over here by putting 3,14, not float. Both are integers, but you can guess. We can actually insert an float also. But it stores also its own data type, which is a list over here. Now guys, think for a moment that why why such a flexibility is provided over here in Python list, that it can, or any other compound data type, that it can store its own variable also, which is very different from if you're coming from any other programming background, right? One of the chief reason, and if you have guessed, full marks to you, one of the main reason is this flexibility is a consequence of Python's dynamic typing system. So nothing is predefined. Nothing is allocated in the memory predefined, right? You are not defining a particular data type. All I'm saying is that, hey, my new list is a reference to a memory object or to a place in memory which is storing, and you can keep increasing it. Nothing is going to change to my new list, right? Whether you are storing a integer, it's still a reference. Whether you're storing a float, it is still a reference. Okay, so so I hope you are getting the intuition behind that, why this dynamic type system gives so much of flexibility in the Python language. Okay. Now let's go to, we have seen how the indexing works, right? This is the 0th, this is the first, second, third, fourth. Okay. Now let's see, we'll go ahead and see how the slicing works. There's another concept which is called slicing. Slicing is nothing but if you have to get a subset of the list, this is called slicing. Slicing is similar what is meant in English. If you have to get a slice of a pie, of a pizza, you are getting a portion or a subset of it. In Python's term also it means the same thing. We'll see it with few examples and it will become clear. Now let's see what is my new L. My new L is still there. Okay. Now let me see that if I want to get only a subset of it, okay, how to define it. Now it's very simple because we have indexes. So the syntax goes like, you have to, the first thing we have to specify that from where you want to slice. Let's see, we want to slice from 0 for second element. Okay, so we'll specify 2, we'll put a colon. Where do you want to stop? Suppose we want to stop 0th, 1st, 2nd, 3rd, 4th, 5th and 6th. Okay, we stop at 6th element. Okay, now when we say 6th element, then remember that when we start, it includes the variable. When we end, it leaves the last variable out. So last variable is not counted. If it's 6th position, 0, 1, 2, 3, 4, 5, 6. Okay, let's run it. So it has started with 2, 0, 1, 2. So it has started with 12 and we have got 12. Okay. Where it is ending at 6th location. So 0, 1, 2, 3, 4, 5, 6. But you see over here, it has not included the number 8. It has included at the 6th, when we mention 6, it will include all the variables up to 6, but not 6th variable. Okay, or the 6th element rather, sorry, 6th element. So a start is included, end is not included, it's before that. So the 6th element is 8, we are counting only till 9. So 12, 11, 10 and 9 will be included when we slice it between 2:6. Okay, let's see it with another example. Okay, now let's see, we want to have, this is 0, we want to start from 0 and maybe go till, let's say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, we have to get the first 8 elements. This is the first 8 elements. How we should define? We should leave the start. When we leave the start, by default it assumes that it is starting from 0. Either you specify 0 or you leave it, it means the same thing. Okay, for the first 8 element we have to specify 9 so that it will leave the 9th element and it will go till 8th element, right? So it is 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is 0th base indexing, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the 9th element. We are specifying 9 over here. It is counting till 4 and that's why the result is still 4 over here, right? I hope it is clear. Now similarly, if you want to let's say count something till the end, start from second but do till end. We do not have to specify any end. If we leave that, that means it will go till the end. Okay, so it is starting from second, 0, 1, 2. So from 12 it will start and it will go all the way to the end. Okay, this is what it means. Okay, now there is a step also which we'll see. So we can actually count that you start from the beginning, go till the very end, and pass the third parameter also, which is a step size. A step size means if I specify a step size as 2, that means every alternate element. A step size as 3, that jump every 2 elements. So jump 2 more elements. Okay, let's see a step size of 2. What it is going to print? It is going to print every alternate element. 14, 12, 10, 8, 4, 2, right? Every alternate element it is printing. It is printing from the very beginning till the end over here with a step size of 2. Okay, now let's see one more example. Colon, colon, start, end, and a step size of 3. So it will leave 2 elements. It will start from 14, left 2 elements, went to 11, left 2 elements again, went to 8, left 2 elements again, went to third, left 2 elements, but we hit the end. Okay, so 14, 11, 8 and 3 are done over here. Okay, so this is how you can do slicing. Three concepts over here. You have to specify the start, the end. If you do not specify, by default it assumes at the beginning and the end. And the third is the step size. Now there is one more beautiful thing which is there is the negative indexing. What is negative indexing? Let's go over here. Okay, so I was saying that this is my list. Let's say PROBE. These are the 5 elements. The indexes are 0, 1, 2, 3, 4. Now Python also supports negative index. That means the last element is also can be referred as -1. The second last as -2, -3, -4 and -5. Okay, so if you can see it's like a number line, right? So this 0, 1, 2, 3, 4 in the positive direction, and if you are coming in the negative direction, it is starting with -1, -2, -3, -4, -5. Okay, remember this. Now let's say I have to access the last element. How I should write? Because I have a negative based indexing, I can write over here. What I should write? Where should I? What should I try to? If I have to do not the slicing but the indexing, I have to just get the last element. What I will do? I'll put the last element. Okay, my last element was 1. With a -1, I can refer to 1. Okay. Similarly, if I have to get second last element, -2. Okay, I got. Similarly, for slicing also, this negative indexing works beautifully. Okay. Now, let me show you something like, okay, you take an example that this len -3 colon, what it will present, what the answer. My start is -3, my end is, I have not defined what it is going to print. Let's say what it is going to print. Oh no, not len is a function, my thing is new L. Okay, new L -3 colon 3, 2, 1. And now see, let's see why it is printing 3, 2, 1. So it is starting from -3. Which is -3? This is -1, -2, -3. I'm printing from -3 going all the way to the end, right? So if you have to pass last 3 elements, or if you have to store or slice last 3 elements, this is a very nice way of doing it. -3 colon 1. Start from -3, the third last element, go all the way till the end. Okay, which is okay. This is very interesting. Now you tell me that what will be the, if I give 2 element and -1, right? If I have to run this, what it will do? It reverses the string. Why it is reversing the string? Because the step size is -1 and your start and end is not given. That means you are going from the beginning end to the beginning, and that's why the string which was 14, 13, 12, 11, it is getting reversed over here. Okay, Now, one other important thing, if you notice that I have already told this particular thing with the dot operator, if you see, it also has a function reverse. So either you can do reverse using this, or you can use a shortcut method, which is over here, right, to reverse a string. The only difference between these two is this creates a new list. When we use reverse, this will be in place. So let me show you, okay, that why it will be in place. Okay, so okay, before that, let's see what is new L now. My new L is this. Okay, I did an operation which is reversing. It output the reversed, but has my new L changed? Let's see. It would not have changed. My new L is still there, right? So this is creating a copy over here, right? It is creating one more list which is in a reverse order. Okay, but what if I do a dot operator and reverse over here? What will happen? It does in place. So now if I print my new L, see, new L has got reversed in place, right? But in case of this, it creates a new. This is the only difference. Okay, rest all the things, if you have to reverse a list, you can use this or this, any of the methods. Okay, now let's see that we have already seen all the functions like insert, remove, which comes with the dot operators, right? All these syntaxes, whatever we have discussed with the list, more or less remains the same with all the compound data types. Okay, now let's quickly move on to tuples. What are tuples? Okay, what is a tuple? So tuple is very much like list, very similar to them. The only two differences are this, that they are immutable. Okay, this is the biggest difference. That means once the tuple is defined, you cannot modify it. Okay, but in list is mutable. Tuples are also ordered. That means it is indexed with it's a predefined order. Okay, it's also ordered like list. The order is defined that this is 0th location, this is first location. The only difference, major difference, is that it's immutable. Once it is defined, you cannot change it. Okay, now let's see how the tuples are defined. Okay, let's see. I define a tuple with, and as I have told you, it defines with a small parenthesis. Okay, correct. Now if I have to get the length of tuple, again the same function, len. It is a 4. Okay, if I have to do zero base, it's also follows zero based indexing. So if I have to access the first element t0, which is 1, which is fine, right? Now, as I was saying that this is immutable, let's try it out. Okay, let me try to assign something which is let's say t0, which is 1. I'm trying to assign it to 4 or maybe 5. 4 is already there. I'm assigning it to 4. You see, it will throw an error. Tuple object does not support item assignment, so I cannot modify. Once I have defined it, it remains like that. Okay, now let me see if I want to append something. Okay, tuple dot append, or again append, which function was there? No, it doesn't have any attribute. Let's see what are the things we can see with the dot operator which are exposed for tuples. You can see it's very small. Either it, and both of them are read type of operations, not modify. It either does count, that how many times a particular element exists, or index. That's it. Okay, so tuple is like a many respect it is similar to list, but it is only used if you have to define once and you reuse many times. That kind of use cases, if those kind of use cases are there, then tuples are very interesting. Now the other way to do that is if suppose there is a need that you have defined tuple and you have to modify it for some reason, there is another way to do that. Okay, and the way would be that it's slightly convoluted way. You typecast that tuple into a list. You can always modify a list, and then you can typecast that list back into a tuple, right? So let's see that how it is done. Let me see, I'm typecasting my tuple, which is immutable, into a list, right, with a constructor. right? If you see the list, I'm typecasting it. Okay, now I did that. Now let me see my type of W. It has become a list. If I print W, it has become a list and it is giving 1 2 3 4. Let's say I have to append a 5 over here. So w.append, that function is there. I will append it with a 5. Again my W, it would have appended nicely. Okay, now I'm going back and I'm saying that convert my list. Okay, sorry, a spelling. Okay, convert my list into a tuple. Okay, now let me see my tuple over here. My tuple is back over here. So I started with a tuple which is 1 2 3 4. I converted into a list with the same. I appended it, I converted it back into tuple. So this is a slightly longer convoluted way, but in case you find yourself in a situation where you have to modify a tuple, this is a way in which you can do. All the indexing, slicing logic which we discussed over here in detail also works for tuples. Okay, so I'm not going to repeat the same thing over here. So we'll move on to now dictionaries. Okay, let's see dictionaries. Let's say dictionaries. Okay, so what are dictionaries? Dictionaries are extremely flexible mappings. They are, as I was saying, that they are key value pairs, right? And a lot of Python internals are written in this dictionary, right? They are hash map, they are key value pairs. So the way to define that is to key colon value, and each individual element is separated by a comma, right? That's it. So now let me define a list over here, or a dict over here. Let me define a dict. Okay, so I think I have already defined. We'll use the same thing. Okay, yeah, my dict. Okay, let's use the same thing. As you can see, it is defined with a key value pair. This is a key, this is a value, this is a colon, which is separates a key and value, and each element, this is the first element, each element is separated by a comma over here. Okay, clear? Okay, now somebody can ask that, hey, I can understand the difference between list and tuple. What is the difference between list and dict? Okay, so one of the difference is list is also similar to dict. It's just that the indexing is integer based. Okay, by that I'm saying that if suppose my W is a list, this indexing is implicit and integer based. So this is my 0th key value. This is my first key value. You can think that it is pre-assumed, it is implicit. Here we are explicitly calling it out, right? This is my key. My key is associated with a value. Okay, here only we are specifying value, and the keys are implicit because they are numeric, start from 0 and increment by 1, right? I hope that this thing is clear, right? You can think of list as a dict and dict as a list in that context, right? Okay, now let's see. Most of the things which are there can be done similarly. What we discussed earlier for list and tuples are similar in case of dict also. Let's see how it is. If I have to access, let's say, my, when we are accessing tuple and list, we are accessing by its index. Here the index is key, right? So if I have to access an element, I have to pass the key value. Key value, let's say I'm passing India. What is it giving? It is giving me the value. Value is New Delhi. Okay, this is how you access a key value pair, right? In case of list, this India was implicit to be 0. Okay, we didn't mention it also, and this place was the first value. But here it is not indexed based on numbers, it is based on the key. Okay, now let's see if you have to insert a new key value pair, right? So let me see how we can do that. So I will see my dict. Okay, and I will do square bracket, and I will try to enter. Let's say I will do Bihar, and I will say its capital is over here, Patna, and I will enter. I will again try to read my dict. Okay, now my dictionary has 4 elements. Okay, Bihar, Patna, as you can see, has been added over here. So this is how you append or add a new element. Okay. Now, since the key is indexed, okay, it will not accept you a duplicate key value, right? Because this is the index. If it will not accept a double duplicate India or Karnataka or Maharashtra or Bihar over here. Let's see what happens if I try to run the same thing again. What it will do is it will not throw you an error. Rather, it will go ahead and update. Let's say Patna new. And I'm going to run the same thing. Do you know what will happen to my dict? It will say that Bihar already exists over here. Okay, my key already exists. It will treat that I'm replacing Patna with Patna new. Okay, let me see. See, it became Patna new over here. It will never accept a duplicate key value over here, and it will not create an entry. Okay, so this is the difference. It will update the value. Okay. Now let's say there are other functions again over here, my dict. So let's see what are the things which are available with my dict. I'll put a dot and I'll put a tab over here, right? And these are the methods or functions which are available with dictionary type objects. Clear, again clears out the dictionary. Copy, copies the dictionary, right? From keys, if you have to get some value from key, you can get that. What does the get does? Let's see. Maybe we can see this get thing. Okay. So what we'll do is we'll put get and we'll put a small parenthesis and we'll see India. Okay. Let's say. So this get and this index based thing, right, which we did over here are similar things. We are getting a key value, passing a key. It was the same thing over here. This is more general approach, right, which is true for even list, tuple and everything. So I would prefer, like I prefer using this rather than using a get operator. Okay. Now let's see that what the other things are available. Okay. So you have something called items. Okay. Let's see. It will list out all the items. Okay. In the dictionary. So you can see that dict items, it is listing me all the items. Okay. Let's again go and see that what other things are items. Keys, list all the keys. Pop removes an item. Pop item removes the both the key value pair. Set default. Update. Update is again like insert type operations. Okay. So we can get that. Okay. So these are the various methods which you can see which are available, and most of them are self-explanatory type of variable methods or functions which you can play around and see that. Okay. Let's say if you have to the update thing was, for example, it's similar to what we are doing over here, right? Patna new, it will go ahead and update. If you pass a key and I pass a new value of that, it will go ahead and update that. Okay. Now let's see what there was a pop method which will go ahead and remove the item with a specified key name. If you pass a key name, it will go ahead and remove. Pop item, it removes the last inserted item. So whichever is the last inserted item, it will remove. The clear, it will clear out. Now one thing to note here, friends, is before Python 3.6, dictionary was an unordered set, unordered list. Okay, or unordered, not list but unordered object. So there was no guarantee of ordering. After 3.6 to from 3.7 onwards, it is now an ordered list. If you insert, then you are inserting at the end. This order that India will appear at the first place, then Karnataka, then Maharashtra, then Bihar, is predefined. Okay, and it is defined in the order in which it has been entered. Okay, so now dictionary has become an ordered list. Earlier it was unordered. Okay, let's see. Okay, so but having said that, all the other things which you are doing with list and tuples which you have done in detail, it is still true for dict also. Okay, major difference, it is not numeric index based or zero based indexing, it is key indexing. So you supply the key and you get the value. Okay, now let's move on to our last item for the day, which is sets. Let me just type it over here. Sets. Okay, so what is set? The fourth and the basic collection is the set. Now this set is unordered collection of unique items. So there are two keywords, unordered and unique item. Okay, they are defined much like sets and tuples, except they use curly bracket like dictionary. So how do we define? Let's define something and then we'll see that what sets are. Prime. So I'm defining two sets. The first is 2, 3, 5, 7, the first four prime numbers, and I'm defining the second one, which is odds, which is 1, 3, 5, 7, 9. Okay, so I'm defining the odd number, the first five odd numbers. Okay, so friends, if you are familiar with what a set theory is, or if you have learned in the basic mathematics sets, this set is also similar to that. Okay, what we say in the maths, and we are represented by Venn diagram and other things, right? So it also has the methods which are union, intersection, difference, symmetry difference, and all the things, right? Python also does exactly the same thing what is done in the mathematical concept. Let's see, if you're not aware, then probably we can go ahead and have a, okay, so what are sets? So let's say we have a set over here of prime numbers, and we have defined another set of, okay, so let's see, this is my prime and this is my odd numbers. Okay, so my prime has the number 2 and 3 and 5 and 7. Okay, my odd is 1, 3, 5, 7 and 9 over here, right? Now we see what is the intersection. The intersection is the common thing between my prime and my odd numbers. Okay, so you can see, friends, over here that there are something which is common. What are the common? 3 is common, so 3 will go over here and we need to delete it from here. Okay, 5 is also common, so we'll put 5 over here and we'll remove 5 from here. 7 is also common, we'll remove 7 and we'll put 7 over here. So if I have to ask you that, hey, what is common or what is intersection of P and O, prime and odd sets, then you can say that this particular region, let me highlight it into a different color. No, not this one. Okay, so if you have to say that this particular region, right, this is my intersection. Okay, now if I have to say that, hey, tell me now that what is the union of it. Okay, if somebody asks you what is the union of it, let's select a different color. The union is everything combined. So this plus this is my union. Okay, so this is the difference between my union and intersection, right? This is the mathematical concept of union and intersection, which is very much similar what we use in the Python, in case of Python also. Okay, so now let's see that what are the methods which are available. Okay, so if I do primes union odds, okay, primes dot union dot odd, I'm doing a union of prime and odds and I'm running it. Let's see what it is saying. It's saying 1, 2, 3, 5, 7, 9. So if you recall over here, it is doing 1, 2, 3, 5, 7 and 9. Over here, these are the elements which is present in prime and odd, and we have removed all the duplicate ones, right? We are only doing the single counting. So we are actually accounting for all the elements, but we are not doing the double counting, which are common. We are counting only at the single time, which can be clear from this particular diagram also, right? If you see, because this is my intersection. Okay, now let's see what the intersection will do. Okay, so for intersection, I will do again primes dot intersection and with odds 3, 5, 7. So 3, 5, 7 is my intersection over here. These are the elements which are common. You can see from here also in 2, 3, 5, 7 and 1, 3, 5, 7, 9. Your 3, 5 and 7 are common. 3, 5 and 7 are appearing in both the places, right? So that is what intersection is. Okay. Now, what is the difference? Okay. So primes dot difference odds. What it will do? Items in primes but not in odds. So what are the items in prime but it is not present in odd? This particular area, right? Let me just highlight that. Your this particular area, if you see, this is present in prime but not present in odd. Okay, now let's run it. So what is present in prime but not present in odd? Only 2, right? 3, 5, 7 is anyway present over here. Now the reverse way, right? What is present in odds but not present in primes? You can see what is present in odds but not present in prime. 1 and 9. See, 3, 5, 7 were the common ones, right? 1, 9 is the only one which is not present. So you can do like that. Okay. Now something is called symmetric difference. So let's say primes dot symmetric difference, and you do odds. This is my second set. What is it doing? 1, 2 and 9. What does it mean? It items appearing in only one set. What are the items which are appearing only in one set? So these are appearing only in one set, right? Okay, so that's what the symmetric difference is. Okay, so this was 1, this is 9, and this is 2. They are only appearing in one set. 3, 5, 7 is in the other set. So union minus intersection is something which is symmetric difference. My union was this, my intersection was this. I removed the 3, 5, 7, the intersection. 1, 2, 9 which is left is my symmetric difference. Okay, so very easy, right? We can understand. Okay, so these were the set operations. Now if you ask me that, hey, where is the practical use of set? Where do we use it? How do we use it? So think of a situation where you have to do the binning, or you have to separate various things. Let's say I was giving the example of this playlist creation, right, on a Spotify or YouTube. So you are putting think it like this. One of the set is my Bollywood songs, the other set is rock song. Okay, now there could be some Bollywood songs which are rock also. There are some rock songs which are Bollywood also, right? So when you start putting it all together, right, in Bollywood category and arts category, and if you are doing, let's say, intersection over here, what you are getting? You are getting all the Bollywood songs which are rock songs also, right? So probably this will give you an intuition that where the sets are used in the real life scenarios, right? And sets are the one last thing which I wanted to make. Its sets are unordered, and you can not have duplicate entries over here. Why you cannot have? Let's say this is my Bollywood song, for example, right? If I put one song over here, I do not want to double count the same song over there, right? It doesn't make any sense. I only want to account that song for one time. So if you want to insert another 2 over here, it will not accept. It say that it already exists. It will not throw you an error, but it will not say anything. If you want to insert like 11 over here, it will accept it because it's a new entry, right? Order is also not guaranteed in case of sets because it doesn't make any sense. Sets is an unordered list by definition. Unordered unique list. Okay. Apart from that, all the things which we have discussed for list, dict, tuples are very much valid for sets also. Okay, I hope this give you a very good understanding of what is list, what is tuples, what is dict, and what is sets. So friends, this brings us to the end of today's session. If you have any question, please comment and I will try to answer. See you all in the next video where we'll discuss control flow of Python, if, else, while, for loops, etc. See you all in the next video. Have a great day. This is ML with AP signing off.